Intel today announced their next generation Xeon Scalable processors, codename Ice Lake. As expected, this announcement puts Intel in competition with their arch rivals AMD and their third generation Milan EPYC server CPU platform. I'm Stephen Foskett, publisher of Gestalt IT, and this is the Checksum. We've spent the last few weeks reacting to AMD's third-generation EPYC server CPU launch, codenamed Milan, and speculating about Intel's response. Well, this morning, Intel did announce their third-generation Xeon Scalable platform, and it's pretty much what we expected. Ice Lake processors get PCI Express 4.0, more memory channels, and an efficiency bump that makes them competitive with AMD's offerings. But more important are the supporting products, notably the Optane Persistent Memory 200 series, Ethernet 800 adapter, and an ecosystem of software technologies. These give Intel's Ice Lake platform something even Milan can't boast. Intel was embarrassingly late with Ice Lake Xeon. But while AMD simply revved up EPYC a little bit for Milan, Intel brought some important new capabilities to their server CPU range. Most important is PCI Express 4.0, which was a big differentiator for AMD's server products until now. Not only did Intel move from 3.0 to 4.0 in Ice Lake, they also added more PCIe channels per socket. Cascade Lake offered just 48 lanes of PCI Express 3.0, but Ice Lake has 64 lanes of 4.0, which is more than twice the bandwidth. This finally puts Xeon in the same playing field in terms of I/O as AMD's EPYC processors, even though they boast 128 lanes per socket. Then there's the situation of memory. Intel moved to 6-channel memory with Skylake SP and stuck to it with Cascade Lake in 1 and 2 socket systems and Cooper Lake in 4 and 8 socket systems last year. But Ice Lake gets 8-channel memory, increasing bandwidth dramatically. Memory speed is also revved up a little bit from 2933 or less to 3200. And this isn't affected even when an Optane Persistent Memory 200 DIMM is used, a topic we'll discuss in a moment. Intel claims that memory latency is much better than AMD EPYC as well, especially when reaching across sockets in multi-CPU systems. Overall, this gives Ice Lake a nice advantage over Milan when it comes to memory. As expected, Intel is also offering more cores per socket with Ice Lake. Whereas AMD Milan tops out at 64 cores, Intel's previous generation Cascade Lake Xeon Scalable processors could only offer 28 cores per socket. Now Ice Lake ranges up to 40 cores per socket. Even though this can't quite match Milan, most customers will be buying lower core count processors anyway because they offer more value for the money. In fact, if you look at the Milan processor offerings, you'll see that the sweet spot is actually processors with 24 or 28 core parts, and anything over 32 cores costs more than twice as much on a per core basis. Although I haven't had a chance to look through Intel's price list in detail since the announcement was just made today, and most hyperscalers, of course, and OEMs are paying their own prices per socket, it's safe to say that very few people are going to be buying the 64-core monster chips anyway, so 40 cores looks pretty good. It's also important to consider the low end of the range for a moment. AMD is still selling their previous generation EPYC, codename Rome, at the low end, with Milan only starting at 16 cores and an MSRP over $1,000 for the EPYC 7313. Intel also moved away slightly from the low end with Ice Lake, but they still do offer an 8-core Ice Lake part. And low-end servers with 8 or 12 cores are pretty common, so Intel is likely to be competing with the previous generation AMD parts in these volume servers. And now Intel will be able to offer PCI Express 4.0 and 8-channel memory just like AMD has. Frankly, I think that this is going to be a very competitive segment of the market going forward. Intel is also pretty proud of some of the enhancements they've made to the Sunny Cove cores they've included in Ice Lake, and this gives them some room to brag against AMD. Notable are the AVX 512 instructions that can accelerate in-memory databases and compression, public key cryptography operations, and vector mathematics. And Intel's deep learning or DL boost instructions are way ahead of AMD in AI processing, and in fact give Intel the opportunity to serve as a legitimate deep learning inferencing engine. Though most buyers might opt for an accelerator card if they're going to be using a lot of AI math. Combined with the optimized cores and better caching, this ought to cut or eliminate AMD's per-core IPC lead in most cases. But the Intel Ice Lake story isn't really all about the CPUs. We've seen many new storage and networking product introductions over the last year, and they seem to be waiting for something. What they were waiting for was Ice Lake. Intel's Ethernet 800 line needs PCI Express 4.0 to reach its full potential, and that just didn't match up with the Cooper Lake server platform. The same is true of the P5800X PCI Express NVMe SSD that we saw introduced in December. And Optane Persistent Memory 200, also introduced in December, really didn't make any sense in Cooper Lake. All of these seemed like accessories waiting for a platform, and now that Ice Lake is announced, we can all see where Intel was going. These things combined make an Ice Lake server much, much better than the competition on a platform basis. And Intel is showing full platform benchmarks that combine the E810, the PMEM 200, and the P5800X in real-world applications with really world-beating performance. The real story of Intel's Ice Lake announcement today is pretty simple. Intel finally has a server CPU platform that's competitive with most of what AMD is offering in their EPYC line, and they've paired it with additional components that nobody else can match. Ice Lake really isn't about a CPU as much as it is about a platform that finally brings Intel into real competition with AMD in the middle of the market, and this is exactly what the company needed to do. I expect that Ice Lake will be enough to keep Intel competitive in the data center and the cloud while both companies work on their next generation server platforms. And that's when things are really going to get interesting, because both companies are re-engineering everything around technologies like PCIe 5 and CXL, and this will totally change the server CPU picture. So the takeaway from today's announcement is that AMD is no longer running away from Intel in the data center, and Intel no longer has to hide their head under a paper bag because they don't have anything competitive. Frankly, from now on, I expect that it's going to be pretty much the two-horse race that we always expected it to be, at least until 2022 or 2023, when we start seeing real next-generation converged infrastructure launched by these two server powerhouses. Thank you for watching the Checksum. I'm Stephen Foskett. If you'd like to reach out to me, you can find me on Twitter at @sfoskett, or you can leave a comment on this post at gestaltit.com. Please check out our videos at youtube.com/gestaltitvideo for more from the Checksum, from Conversations and the Rundown News Show and our podcasts, as well as all of the content that we post on the gestaltit.com website. Thanks for joining us, and we'll be back soon with another News Checksum.